All right, so get your notes out, please. We are moving on to section 5.2. I have some notes I'm going to give you. Yes, you have a homework copy tomorrow, but I think I gave you those assignments on Tuesday, so you've had Wednesday, Thursday, Friday, the whole weekend, and Monday to work on them. So I think you've had ample time. If you did not get it done, you've got some business you need to take care of. So I am available if you want to come in before school tomorrow. You are welcome to come in and get a little bit of extra help. But we are moving on to section 5.2. And what we're going to do is start working backwards now, and we are going to take the integrals of natural logs. So far we have only worked on, in this chapter, we have only worked on finding the derivative of natural logs. Now we're going to work backwards and find the integrals of natural logs. And I think the hardest part about this is going to be remembering how to find the derivative and then how to work backwards and find the integral. So what we're going to do one of these days, maybe not tomorrow, but maybe on Wednesday, we are going to work on putting them together. One problem will be a derivative, another problem is going to be an integral, okay? So working back and forth. I think that's probably a good way to approach that, because then you are remembering rules from one to the other. All right, so if of f of x is equal to the natural log of u, we defined that last week as, we just find the derivative of it as being u prime over u. That shouldn't be new information. That stuff you should be actually pretty good at by now. But I would like you guys to see this also could be written as 1 over u times u prime. Those two things mean exactly the same thing. I just factor out 1 over u. Multiply it by u prime, you get u prime over u. So, the integral of u prime over u equals what? Is the ln of u. If f of x is the ln of u, then the derivative is u prime over u. Well, if you work backwards, that means you're taking the integral. So the integral of u prime over u is exactly what you started with. It's your function that you began with, which is equal to the ln of u. And typically what you will see is the u in absolute value symbols, because you remember you cannot take the logarithm of a negative number. Okay? Sometimes these things are necessary. Sometimes the function can never be negative, and we'll talk about some of those when we get to them. Sometimes it can never be negative, so you don't need the absolute value signs there. Okay? All right, an example. Can I flip? What is the integral of 2 over x dx? So, when we were just talking about the integral, we defined the integral as being u prime over u, or excuse me, the derivative as being u prime over u. So, what you need to do in this case is when you define your u over on the side, this bottom right here is your u value, and then this part up here is your u prime. That's, wait, don't write that down. We need to find our du. Let me come here. U is equal to x. The bottom is what we call u. What is u prime then? In other words, what is the derivative of u? It is 1. And remember, when you find the derivative, you tack a dx on at the end. So 1 dx is u prime. So what we need to do is make this look like 1 over x times 2 dx. Are you okay with what I just did? I took this 2, and I just move it to the side and make this 1 over x times 2. If I multiplied these two, 1 over x times 2, you would get 2 over x. So 1 over x times 2 is the same thing as 2 over x. And the reason I'm writing this is because I want you to recognize that this 1 dx is the same thing as u prime. So this really means the integral of 2 times u prime over, what's on the bottom? There's an x on the bottom, and x is actually u. Well, what is the integral of u prime over u? It's the ln of u, and then that has to be multiplied by 2. So this really means 2 the ln of u, which really means 2 the ln of, when I replace the x back in for u, it's 2 the ln of x. All right, now, can you take the natural log of a negative number? You can't take the natural log of a negative number. But can x ever be negative?
Yes.
X certainly can be negative. In this case, you're going to want to add your absolute value signs in because this only works if the x value is positive. By the way, we are finding an indefinite integral, and whenever we find an indefinite integral, what do we need to add on to the end?
D by
We need a plus c at the end.
D by dx.
Yeah. Can you what? Yeah, and will you close my door too? Just don't close it tight. Okay. All right, let's try this. The integral of 1 over 4x minus 1 dx. The bottom is always the u. So that's what you want to do. First of all, is go to the side and name u 4x minus 1. U is equal to 4x minus 1. What is the derivative of u then? U prime is equal to 4 dx. But over here, we don't have a 4 dx, we have a 1 dx. So do you recall what we did over there? We divide by 4. We divide by 4. We divide by 4. So this 4x minus 1 is on the bottom. So I'm going to put a u on the bottom. And then on the top, I'm going to put a 1 there. And dx is actually equal to u prime over 4. That's what I have here. This dx times 1 is the same thing as dx. So I really have a times u prime over 4, which is equal to the integral of. I want to get this u prime over u together. So I'm going to do a rewrite of this as 1/4 times u prime over u. Are you okay with that? We're multiplying fractions, top times top, bottom times bottom, so it doesn't matter what order the top and the bottom are in, as long as they're all being multiplied and the top stay on the top and the bottom stay on the bottom. What is u prime over u? What is the integral of u prime over u? It is the ln of u. What goes in front?
1/4.
The constant, which is 1/4. Not plus c yet. Yes, technically yes, but I'm not going to put it there until I substitute my u back in. So this is 1/4 the ln of u. What is u? 4x minus 1. I have to decide if I need the brackets there, the absolute value of r's there. Not could 4x minus 1 ever be negative? Yes, it could be negative. So if it's negative, could be negative, I have to put the bars there. Let's see. Probably not. Yeah.
So why did you multiply the 1 over u times u prime over 4? Because you know.
Well, I didn't. I mean, I just wanted to make it look. I wanted this to say u prime over u, because I know that the integral of u prime over u is the ln of u. So I just wanted those to be together so I could see that I did in fact have an ln of u there. So I just reordered it. This right here, this 1/4 is a constant. I know I can just take that out. And I'm just left with u prime over u, which is ln of u. the first step. You
Wait.
take your denominator, call it u.
No, that's not that first.
Okay.
The first thing you wrote.
The first
after the-
1.5 steps, is that what you mean?
Well, the one with the big heart butt cheek circle. The heart butt cheek circle. Yeah, that's what I was.
Heart butt cheeks.
You're okay with all of this stuff over here?
Yeah.
Okay, so u prime over 4 equals dx. Well, this right here on the top, 1 dx, that's the same thing, 1 dx is the same thing as dx. Okay, so I took this 1 dx and I replaced it with u prime over 4. But I still have this 4x minus 1 left, and it's a u and it's on the bottom. So I had to put this on the bottom, and so what's on the top? A 1.
She didn't.
So then these two together, those two together, I put them together over here on the right, u prime over u.
Yeah, I get that.
Okay, all right. All right. Let's try another one. All right. The integral of 3x squared plus 1 over x cubed plus x dx. Go over here to the side. What are you going to call u?
X cubed plus X.
It's the denominator, x cubed plus x. U prime is equal to
3x squared plus X.
3x squared plus 1 dx. Doesn't that look very familiar? 3x squared plus 1 dx is all of this. So this and this are exactly the same thing. So this can be rewritten as u prime over u,
Which is the
which is the ln
ln of u.
of u, which is the ln of
X cubed plus X.
x cubed plus x. Can x cubed plus x ever be negative?
Yes.
Yeah, it can be. Yep.
Plus C. Are there
Plus
any problems
C.
for finding?
Yep, I think one comes up here shortly, actually.
Oh, so we only do that extra stuff when the top and DS.
When these things do not match perfectly, then you're going to have some extra stuff to do. And sometimes they will be very, very simple, and sometimes they will not. Okay? All right, let's try. Let's try this one. All right, the integral of x plus 1 over x squared plus 2x dx. What's u?
X squared plus 2X.
X squared plus 2x. The derivative of this is going to be 2x plus 2. Does that match what I have over here? It does not match what I have over here. I have an x plus 1 over there. Over here I have a 2x plus 2. But you could write u prime as 2 times x plus 1 dx. I don't think that's hard to recognize, that you could factor something out and have it look like the numerator. All right, so we have x plus 1 dx right here, but I have a 2 in front of it, so what do I need to do to get rid of my 2? Divide by 2, so you divide this side by 2, divide this side by 2. So x plus 1 dx, this right here, what does it mean? It means u prime over 2, so I'm going to do an integral of, I'm going to have a u prime over 2 here. What about this x squared plus 2x? What is that?
U.
That's u on the bottom. So what do I put on the top of it?
1.
You put a 1. And we're multiplying these two things. So this can also be written as 1/2 times u prime over here, over u. So this, I wanted these together again because what does that mean to you?
ln of X.
It means the ln of x. So the integral of 1/2 u prime over u is 1/2 the ln of u. Is that making a little bit more sense now? Okay. is equal to 1/2 VLN of u, which is x squared, plus 2x, and of course we need a plus c, but do I need the brackets? Do I need the absolute value signs? Or could I just put parentheses there? Be careful with this one because you're squaring x, so you're definitely going to get a positive when you do this part right here. Definitely going to get a positive because you're squaring it. But is there some number that when I square it and then add it to 2 times that same x value that would get you a negative?
Yes.
No. I'm thinking, what about -1? If I did -1 and squared it,
It's 1.
I would get a +1. But then when I were to add 2 times -1 onto it, that's -2. So I really have 1 plus a -2, which is a -1. So yes, you could get a negative number when you do x squared plus 2x. So do I need the absolute value? Do I need the absolute value bars?
No.
Yes.
Yes.
Where did you get that one?
I just said I was trying to decide, could this ever be negative? Could this function right here, could it ever be negative? And so I had to think of possibilities that would make it negative. Okay. So x squared plus 2x, I know if I put a negative in for x, I still could potentially get a negative number. If you can come up with one time when you could get a negative number, then you found a situation when you could get a negative and you have to put the absolute value signs there.
With any number?
With any, yeah, you could make that work with any number. Yeah, you can, yeah. All right, I have one more example for you. Am I done with this? I am. Yes. Okay. All right, are you ready for this one? You got to think back to last year for this.
Side, closer.
X squared plus x plus 1 over x squared plus 1 dx. What do you? What's your prime? We have an x squared plus x plus 1 dx. It does not at all match what I have over here for u prime. So I'm going to put a big old message here, reminder, a note in my notebook that does not match. So when that happens, you need to go back to your original function, x squared plus x plus 1 divided by x squared plus 1, and you have to decide if there's something else that you could do with that. I see a division problem with polynomials. And if you remember from last year, you had to do these things. And you had to divide it into x squared plus x plus 1. Do you remember these? Now, some of you, I know when I was going over these again, I was like, oh, can't we just use, do you remember synthetic division, how nice that was? If you would like me to, I can refresh your memories on synthetic division, but I want to remind you that synthetic division only works if this number out here is linear, if this polynomial out front is linear. It only works if it's linear and if the coefficient in front of the x is a 1. It only works if it's a regular x and a 1 out front. Sorry, guys. So in this case, we got to do the long way. And I know these are not fun. In fact, I'm going to be honest with you, I don't really like them very much either. But, all right, here we go. How many times, and this is what you do. You start out here with this thing. And you decide how many times can you divide x squared into x squared? Once. So where do you put your 1?
The top.
Where do you put it on the top?
Above it.
Above.
Above x squared.
Top, above. Not under.
Above
What do
x squared.
Well, not. I mean, if it only goes in one time, there's no x involved at all. So you put it with the number that doesn't have the x. So technically, it goes here. But if we can be honest, it doesn't really matter. If you get it up top, you get it up top. It doesn't really matter. All right. really, I think when you were taught to line them up as such. If x squared goes into x squared one time, you put the 1 above the constant. All right, now you take this 1. You guys are looking at me like you were not taught that, were you? 1 times x squared. What's 1 times x squared? X squared. All right, now the deal is you don't have any x's here in the middle. You have 0 of them. So technically you're going 1 times 0x is 0x. And then 1 times 1 is 1. Now, when I have taught this in the past, this is where I now take this new polynomial and I throw some parentheses around it, and I throw a minus out front because you're actually subtracting that whole polynomial. And when you subtract that whole polynomial, that means that you are actually adding the opposite of this. You are adding the opposite of 0, which I'm not going to change. And you add the opposite of 1, which is negative 1. And now you go through and you add them up. So x squared and a negative x squared, they cancel out. You still okay with that? You have an x and a 0x. That gives you a total of x. And then the 1's cancel out. So what's left over? An x. So at the end here, you have a plus x over x squared plus 1. So this quotient, that's when you did a division problem, so your answer is a quotient. That quotient is the same thing as your original problem. So I am going to rewrite the original problem as not x squared plus x plus 1 over x squared plus 1. Instead, I am going to do a rewrite of 1 plus x over x squared plus 1 dx. This is why you learned how to divide polynomials last year for situations like this. Aren't you so grateful now?
We didn't learn that at all. It was lucky too.
All right, so now what you need to do is take the integral. Now, the only part that's going to cause you grief here when you're finding the integral is this part right here. So you go back and do the u stuff we've been talking about. Look at your denominator. That's u. Well, isn't that what we already called u over here? We've already done the work right here. I have an x dx. Over here I don't have x dx, I have 2x dx, so what do I need to do?
Divide by 2.
We divide by 2. So divide this by 2, divide that by 2. So this really means the integral of 1 plus x dx really means u prime over 2. And I have that x squared plus 1 on the bottom, which is a u. What goes on the top of it? A 1. So I'm going to do another quick rewrite here. This is going to be the integral of 1 plus 1 half u prime over u. Well, what is the integral of 1 half u prime over u?
1 half ln.
1 half ln of u. All right. What's the integral of 1?
X.
It is x. So this means x plus
The ln of x squared.
1 half the ln of u, which is the same thing as x plus 1 half the ln of x squared plus 1. Let's talk about that. X squared plus 1. So you take any number, any x value, you plug it in here and you square it. What do you get?
Positive.
You get a positive. And then you add 1 onto it. What do you get?
Positive.
A positive. Do you need the absolute value bars there? No, it will never, ever, ever be negative. So no need to put the absolute value bars there. But I want to say one more thing. I will accept either answer, but I also want to mention to you that this 1/2 right here is out front, what can I do with it? You could make it an exponent, so you could put this to the 1/2 power, which really means square root of x squared plus 1. But you can only do this if you don't have the absolute value bars there. Okay? Only if you have you don't have absolute value bars there. And of course, I need to add a c at the end.
So after you divide, you keep the same u and you prime.
Yeah, it works out nicely because when your denominator is what you call u. And that doesn't change. Even after you do your long division, your denominator of your remainder is still going to be exactly the same as the denominator in the original problem. Okay, so your u's stay the same after you do the division.